Here I am going to discuss about addition of two 16-bit numbers. Addition of two 16-bit numbers. Okay. Before that, we will draw the flowchart of okay. Then for adding, first we have to draw start button. That is, for adding two numbers, first we will draw the start. And after that, we have to clear the accumulator content. If any content is present in the accumulator, that we will clear. Okay. Clear accumulator. After that, we have to load the two 16-bit data. So that first we will load the first 16-bit data into the HL pair register, because we are doing 16-bit addition. That's why we will load 16-bit data. Load 16-bit data into HL pair register. Okay, now we have load the first 16-bit data into HL pair register, and after we have to load the second 16-bit data, so that we have to move the contents of HL pair into another register pair, so that we will move the content of HL pair into DE pair. Okay, after that again we will copy the second 16-bit data into the HL pair, so that second 16-bit data we are copying into HL pair. Now we are having two 16-bit data, one in DE pair and another one is in the HL pair. Now we have to add these two data, that is the contents of DE pair we will add with the contents of HL pair, and the result will be stored in the HL pair. Okay, and this data now after addition we have to check is there any carry is present. If is there any carry, we have to increment the content of the accumulator to indicate the carry. Okay, so that we will use this block. This is to check the carry. Okay, and here we will check is there any carry. Is carry is there. If carry is there, we will increment the content of accumulator. If there is no carry, then directly we will copy the content of HL pair into content of HL pair into the HL pair into the output memory location. Okay, and if there is no carry, if is there any carry, now we will write like this. If is there any carry, then if no carry means directly we will copy the data into HL pair. If is there any carry, then we will increment the data of accumulator, so that we will if there any carry, then we will increment the accumulator content, because starting itself we have made accumulator is equal to 0. And after that what we will do, we will copy the data of HL pair into output memory location. Okay, output memory location. And if there is no carry also, we will do this step directly. We will copy the data of HL pair into output memory location, which one we have specified for output. And after that, if any carry is present, and then the accumulator content will be 1. If there is no carry, then the accumulator content will be 0. That will also will copy into another memory location that will used for storing the carry. Okay, and finally we will stop the program. Finally we will stop the program, and this is the flowchart for adding two numbers. Okay, now we will see how we will write the program. Okay, before that we are assigning some memory location for the input and output. Okay, suppose the 4200 4201 will the memory location for storing first 16-bit data, and 4202 and 4203 is the memory location for storing next 16-bit data. First 16-bit data is 54 and next is 32. Okay, and after that 4300 and 4301 is the memory location for storing the output data, and 4302 is storing carry content. Okay, now we will start to write the program. And first we have to clear, after starting first we have to clear the content of the accumulator. Okay, so that directly we will load a 0 into the accumulator. For that we are having instruction mva a comma 00h. This means that the content of accumulator now it will be 0. Okay, now next step we have to load the content of 4200, that is 05. Here we have already know the content of first 16-bit data will be stored in 4200 and 4201. That's why the content of 4200 will load into L register and 4201 will load into H register. For that we are using this instruction, that is LH LD 4200. This means that the now the H register contain L register contain 04 and H register contain 02. Okay, and after executing this instruction, the L suppose this is HL pair, then the L contains 05, this will be L, and H containing 04. Okay, after that we have to move this register content into another, because we have to load the second data. Then what we will do, we will move this data into second register, that is DE. That means now after moving this data, the E register will contain 05 and D register will contain 04. For this we are having this instruction. What we will do, we will just exchange the data of HL pair with D pair. For that we are having instruction XCHG, exchange the data of HL pair with DE pair. Okay, now we have exchanged the data. Now the DE pair contain the contents of HL. Now we have to load the second data, so that now the 4200 and 4201 data is already loaded. Now next is LHLD 4202. Okay, what is the content in the 4202? That will move into L pair, and what is the content of 4202? That will move into H. Okay, that's why now the HL content, the L that will be 03 and H will be 02. Okay, this is the data we have stored. Okay, now we have two data, one is DE and one is HL. Okay, now if we are writing in the binary form, this will be 0 1 0 0. We are writing in the 16-bit format, then this will be first data we can write 0 0 0 0, then 4 will be 0 0 1 0, 1 0 0, then next data will be 5, that is 0 0 0 0 0 1 0 1. Okay, that will be the content of DE. and the next content of H will be 0 0 0 0 0 0 1 0, that is 2, and then 0 0 0 0 0 0 1 1. Okay, now we have to add this two data. While adding 1 1 1 0 carry 1, then 1 here will come 1 1 1 0 carry 1 1 1 1 0 carry 1, then 1, then 0 0 0 0, like that. Here also 0 1 1 0 0 0 0 0. Okay, now the data will be, this will be 0 3, and this will be 0 8. Okay, this is the result of this addition. Okay, now here we don't have any carry. Suppose if you have any carry, that means after this addition one extra bit is coming here, then the carry flag will set. Okay, now here there is no carry, that's why the result will be 0 3 and 0 8. Okay, this will be the result. Now here we have to we have moved the data, and one data contained in HL pair and another one in the DE pair. Okay, now after this we have to add this two 16 bits digit. That's why what we will do, we will use the instruction DAD. That means the content of HL pair will add with the content of DE pair that we have seen. Okay, now after addition we have to check the carry flag, because after addition if there is any carry, then the carry flag will set. Okay, that's why J and C, jump not carry. If there is no carry, we have to jump to this location, that is here we can write skip. Okay, if there is no carry, then what we can directly load the data into the memory location. Okay, so that the skip will come here. If there is no carry, then what here we will do, we can store the, and one more thing is there in 16-bit addition, after the addition the result will be stored in the HL pair only, so that if there is no carry, then data in the HL pair we have to store in the output memory location, and the output memory location already we have given 4300. And to store the data into output memory from HL pair, we are using the instruction SHLD 4302. Okay, that means the L register, what is the whatever the content in the L. Now see, 03 will be stored in the H and 08 will be stored in the L after addition. And after SHLD instruction, the 4300 memory, that is 4300 memory will contain 08. That means the L content is moved into 4300, and 430 will contain 03. Okay, like that. If we are SHLD 430 4300, okay, 4300, that means the content of L register will in the 4300 and H register will be 430. Okay, now we have to store the content of accumulator into another, that will indicate the carry. If there is any carry, the accumulator content will be increment. Okay, that here we will write. If jump no carry, we will directly store the data into 4300. If is there any carry, then already we have set accumulator equal to 0. That's why here we will increment the accumulator content. For increment, INR is the instruction, INR A. That means we will increment the accumulator content. Now we will directly store the output into 4300 and 4301. And next step, we have to store the content of accumulator into 4302H. Okay, this indicate the carry. Okay, and final step of a program is to, we have to stop the program, that we are indicated by using the instruction HLT. Okay, this is the program for addition of two 16-bit numbers. Okay, after final instruction we will get the content of 4300 will be 08, and content of 4301 will be 03, and 4302 will be 00 because these are the output 16 bit and these are the carry. If is there any carry, then this will be 1. Okay,